Hello,
Yes, Taha.
can I have passport of meat?
Mm-hmm.
Send to me, please.
Yes,
Insha. Passport of meat.
you are asking me.
Eh?
The
What
passcode.
password do you mean? The barcode? Okay, we'll send it in the group.
Yep.
We send it.
Can you send it in the chat of Zoom? Because I'm the
Yes,
in Europe.
Mr. Taha, you're speaking to me.
Sorry, sir. I will send it to you. Just a second. Professor Rafiq, we will just wait for a few minutes,
Mm-hmm.
and then we will start.
Who is going to join today's program? Already 9 participants is recorded here.
Welcome to all attendees. In a new lecture presented by Basra University for Oil and Gas SB Student Chapter. The title of the lecture, Orange Hydrogen, the Golden Zero Carbon Energy Direct from Uneconomic Oil and Gas Reservoirs. Welcome, Professor Rafiq Al-Awwal. We are very pleased with your presence here with us. Thank you for coming. I'm Dulfiqar Raghib. I will be a moderator here with you tonight.
So the microphone is passed to me or someone else?
On behalf of our SB Student Chapter Board, I would like to welcome you in this session. And now the mic is yours, and let us listen to the great story of the golden hydrogen. We can start.
Okay.
Thank you.
Thank you, Mr. Yusuf Taha. I'm very pleased to be able to present this webinar. And let me start with the name of the Creator, the merciful and the most compassionate. And it is a great pleasure that I'm addressing from India, where the message from ancient Mesopotamia by Prophet Ibrahim alayhi salam has reached, and it is as though I'm responding back in some kind of way to serve humanity together with you. So I am Muhammad Rafiq Al-Awwal, and a former Carnegie Professor of Petroleum Engineering at Texas Tech University, which is located in the West Texas. It's the high plains, like a plateau, 3,000 feet above sea level, beautiful weather. And I raised my family there. And I developed lots of ideas while teaching at the university, both undergrad and graduate courses in the areas of petroleum production engineering, at the advanced level of hydraulic fracturing. And during that time, I also developed or invented a new fracking or well stimulation technology, because I didn't like this brute concept of hydraulic fracturing that was discovered by accident, and it is doing lots of harm to the environment. And so in 2009, I wrote, I was invited by one editor, actually vice president of John Wiley Publishing House, to write the leading chapter of a book called Environmentally Conscious Fossil Energy Production. It included oil and gas, coal, and other environmentally friendly forms of fossil fuels. So my chapter was the leading chapter, and since then I devoted myself to mitigate the environmental damages that has been done since let's say 1870, when this oil exploration and exploitation shifted gear to a very to the level of hundreds of thousands of barrels per day. So having said that, let me give you a quick overview of my trajectory. Starting with my education, I did my undergrad in BTech Petroleum Engineering from Indian School of Mines in India, which is now called IIT, Indian Institute of Technology, and then went to this National Oil Corporation of India called ONGC, Oil and Natural Gas Corporation, where I had the privilege of working offshore platform like this picture on the left as a well completion engineer. And believe me, I learned all those nerves and veins of actual well and how they are completed. What are the pros and cons? There are lots of cons that helped me to charter a new chapter in petroleum engineering, and it is unfolding. Then I thought I would forget the calculus if I continue to work in the field as a field engineer. So I resigned and went to King Fahd University of Petroleum and Minerals in Saudi Arabia for my master's. And having, as soon as I finished that, I got a call from University of Oklahoma for my PhD with assistantship. I did that, and immediately I came back to after finishing. King Fahd University has a research institute. So I joined as an assistant professor and also research engineer, and in a new emerging subject called petroleum geomechanics that deals with hydraulic fracturing and drilling multi-directional wells, which are difficult. And Saudi Arabia had big problems in 1992, 1995. They call it borehole collapse when they drill in offshore, deviated horizontal wells. We had research projects given to us, and we solved that problem. And then I thought it's time to move again back to America. So I joined Texas Tech University, and that was a golden period of my academic career and research career also. And that research led me to an invention, and which drew the attention of the third largest oil company in US, ConocoPhillips. So I was asked by them to develop a advanced hydraulic fracture research center to begin with, and then carry on my invention, which didn't happen because the oil price came down, and they shut down the R&D division completely. So I moved back to academia, but not in America. I was looking for a new university with a new program, and that opportunity came immediately, and I took it and established the Department of Chemical and Petroleum Engineering. And I had some say there, and after that, I thought I'm now matured, so it is time to collect all the experiences and see all the shortcomings of petroleum engineering, especially from an environmental point of view. And having known that the world has woken up and a very mighty platform was formed in 1992, that the nations FCCC framework convention for climate change, and it has given lots of motivations to continue my march towards, and not only environmentally conscious petroleum engineering, but energy in general. And orange hydrogen production is, it stems from that motivation, which started, as I said, that this continuing, battle by the world under this this platform, even FCCC, to solve this big problem, CO2 emissions. Of course, CO2 is not only the greenhouse gas. They have also CH4, methane gas, and H2 and nitrous oxide in a lesser extent. But I would like to, while I pass on to my next slide, I would like to draw attention to this caption over here. It says methane from sheep and cattle, landfills, and rice paddies, which are non-anthropogenic, natural thing, but the anthropogenic, that man-made part, is for some reason missing, intentionally maybe, I suspect, because that's a methane emission footprint by the oil and gas companies offshore and onshore is a huge one. And even without any data, we can say that it has been happening since the early days, as early as, let's say, 1870, and continuing more and more. I'll pull the slide to emphasize on that. So let me continue with this current one. So let's see what the IPCC is doing. They are doing many things. So I pick two things from the agenda of IPCC. One is, we know all of them and feel happy, but not myself. The first one is this carbon capture, storage, and sequestration. And the big oil is very happy. They're, smiling in a year, 2 years, they're greening, and they see a bonanza, lots of money expected from the government, let's say US federal government for ExxonMobil and others, and they'll add a little more money and create some, and in the offshore Houston, in the sea lane, their carbon dioxide injection facilities on a huge footprint, and also onshore. And that is, I call it the specter of what they call it, a large scale maritime disaster. That is a matter of substance for another presentation and lots of papers. But and I picked that knowing that what they are doing. I wrote letters to the vice presidents, and some other research, scientists in ExxonMobil. They don't respond. I wrote to the president of Society of Petroleum Engineers on record. They keep quiet. I call them. They say, well, because they have no answer. So the good thing that IPCC, believe it understands carbon capture, storage, and sequestration. But I must say that from engineering point of view, they do not understand the fallacy behind it. So it is our collective duty to bring that matter to the attention of the United Nations Intergovernmental Panel on Climate Change, and we'll do that starting from here. And the other good thing, of course, the IPCC is doing that endorsing hydrogen from fossil fuels. And they have put some color, funny names, gray hydrogen, blue hydrogen. Everything basically is centered more around this carbon dioxide sequestration, which falls into the agenda of ExxonMobil and associate, or big oil and associate, to make money. They give me your CO2, I'll inject millions of tons of it, offshore in Houston, Gulf of Mexico, onshore, and maybe in other countries where they operate. And they're very happy about that. And gray comes from the coal gasification, of course. And then blue hydrogen, this is a buzzword now because steam methane reformation using natural gas at the feedstock or the source material. So, and the process, all these two processes are done at the surface plants as huge as any refinery or petrochemical complex, and they separate the CO2 to feed to those sequestration wells. I'll talk about that. And here I put this title over here, the fallacy of carbon capture and sequestration. Gentlemen, there is no conspiracy theory here. It is pure engineering and as fundamental as physics that anyone will understand. Even a layman will understand. You don't have to be a scientist, let alone a rocket scientist. You don't have to be an engineer. What is the fallacy? Let's look at this must-have picture of carbon sequestration, which means capturing this carbon dioxide from the major emitters, factories, chemical plants, whatever, and give it to them. And they say, we are the leaders since 1870 in drilling and well construction engineering to deep depths, 4 kilometers, 5 kilometers, 10 kilometers, no problem. We put steel casing and we seal the space between the earth, the rock layers, and the casing with cement. That is, of course, Portland cement that civil engineers use. And then we will inject them into these deep saline aquifers with coal. They even did spare coal mines. Oh my God, those cleats, fractal core, they want to inject there, hoping it will stay there. And then, of course, they say, you know what? There is a thing called enhanced oil recovery. It is a textbook material for petroleum engineers all over the world. This is a very funny again, okay? There is no active projects in any oil company to make money using enhanced oil recovery. Somebody tried and lost money, but the caveat remains there. Now the thing I'm saying that everyone will understand, look at these wells. These are made of steel pipes, and behind them is cement. And the steel will corrode. The deeper you go, the temperature rises 200 to 300 degrees Fahrenheit. And the rock, which is porous rock, permeable rock, they contain brackish water, salt water, which has salt content more than sea water, double the amount. So that's the heaven for corrosion. It is corrosion heaven. And during the operating life of the oil and gas wells, the oil companies, they adopt cathodic protection system in every well so that it doesn't corrode out and become useless and before the oil is extracted. But ultimately, they leave those wells, that's after 20 years. And then what happens? No more cathodic protections. They will corrode faster. And the cement, the poor cement, they degrade so fast. And everyone knows about those RCC breezes on shore or the buildings, how fast the cement degrades. So let's say maximum 100 years, after these wells are drilled, and then 20 years after that, they are abandoned. They are sure, you can bet that they will be completely, they lose the seal and the containment will be lost. Now, even worse is that when you inject CO2 here, you inject under pressure above this lithostatic or the hydrostatic or the what do you call it, the pore pressure in those porous permeable rocks above. So there, that's the worst battle. When we leave these wells, in a oil field and gas field, after depleting the reservoir, the pressure comes to so low. Still, the leaks starts, after that. Now, if you put millions of tons or billions of tons of CO2, okay, into these, the pressure will, go up like anything. Fractures will be created. And they run those, funny, finicky numerical simulation models to show colors and tell the people that no, it will be sure. So I asked them, let us do an experiment, and they don't show up. Okay, so this is the fallacy, and this is very well known that it is not only this failed cement seal around the wellbore, but also this contact. When even before failing, they have lots of pockets where the cement would not go, so that from the production zone, which contains oil and gas, they're leaking continuously. This is a fact. Okay, so this is the first part, and I'm saying this because this gives a strong incentive or motivation to go to bypass, to tell the IPCC, please don't go for this sequestration. Okay, this is the real story. If you put billions and billions of tons, underground CO2, and you're only creating a time bomb there. After 100 years, forget 3,000 years, they'll come back like anything, and at the same time, because you're injecting at the same time in a 10-year frame. Okay, so that's a so dangerous a thing. It is going to be the mother of disasters. There is no question about it. So it is not only the plumes of the methane, but also it will be the carbon dioxide. If you go ahead with this carbon dioxide injection scheme under the cover of carbon capture, storage, and sequestration. So we need to have a paradigm shift. I'm talking about paradigm shift at the level of the United Nations, that powerful forum, IPCC. That means the governments in the Eastern Hemisphere, they need to come forward, and we'll do that. We'll give presentations so that our policymakers in the Eastern Hemisphere, the government level, they can make informed decisions about this, and they can come out with really robust, for example, mechanism for emission abatement to the extent possible, So, so the paradigm shift here is that we can produce hydrogen in situ. In situ means inside the sealed geological warehouse of nature. I made a little simpler expression for the non-technical people. That means the nature itself has the reservoirs sealed with shale rock over there, on top. I'll show a picture after this. So that's why those oils and gas, they have been remaining there after they were produced by geological processes for millions of years until we puncture that seal through a drilling process, So we can create the hydrogen right there. We don't have to produce oil and gas. That chemistry, and more importantly, the chemical process engineering is well established 100 years ago. More than 100 years ago, 1925. So I'll show some slide on that. And what we can do as of now, the new technology has come that's called membrane separation. So while we can cook hydrogen in the reservoir and the byproduct will be CO2, the CO2 will not be allowed if we put those specific membranes at the bottom of the well, okay, to keep it and not allow passage to CO2 and some carbon monoxide and other obnoxious gases. They'll remain. And the smallest atom in the world, in the universe, which is hydrogen, they'll freely pass through that membrane and be produced to the surface. So in one shot, we are killing actually many birds in one shot, if you like that old English idiom. We are not producing CO2 and other those obnoxious gases at the surface, refineries and in the from the pipeline and other facilities. We are not producing it at all at the surface, and that's a huge amount of those gases are leaked from those facilities. They call fugitive gas emissions. That's a huge amount, and the IPCC has some protocol on that, but that is not enough, certainly not enough. So the first thing is, let's not let it come from under the sealed geological warehouse, those CO2 and other things. And of course, that means there is no need of carbon dioxide injection. This is very bad news for big oil. Very, very bad news, because they are planning so much to earn trillions of dollars by becoming the leader of carbon dioxide injection in the name of sequestration. So, and I said that there is no conspiracy theory. This is simple fact of casing corrosion and cement degradation. We can see it at the very good conditions in the RCC buildings, RCC bridges everywhere. The iron corrode, and I give an example of King Fahd University. Those big buildings, RCC buildings, I've seen they're being peeled off and sandblasted, and those rivers replaced at the foundation level with a huge budget. And you are talking about surface environment, 200 to 300 degree Fahrenheit temperature, and salt water, which is double, contains double the amount of salt of some concentration than seawater. So we need to talk about this in situ production of hydrogen from light oil, from heavy oil, from anywhere, and from gas reservoirs, whether they are commercial natural gas reservoir or marginal or non-commercial like sour gas, like the UAE and Saudi Arabia. They have huge gas reservoirs, but it contains hydrogen sulfide. So that's not commercial. They are putting lots of money to bring that CO2, making sure it doesn't leak off, fugitive becomes fugitive, and then strip of that sulfur, so it becomes so expensive. Now, if you go for orange hydrogen, you don't have to do that. You save trillions of capex. My God, I can't believe it. So this is the picture I promised, that the in situ production of hydrogen, that this is a typical picture we show in petroleum engineering or in petroleum geology classes and courses, that how oil and gas occur. So this particular, we call this dome-shaped or a roof-shaped structure called the anticline. This is the signature or indication which we get from seismic mapping, seismic survey, that there could be some storehouse for oil and gas. Why? Because oil and gas are lighter than water. So these are all porous permeable rocks. So the water and oil and gas, which remain there for millions of years, they separate under gravity because of density difference. Why? Because they are held there. This is called the shale rock. This is a seal rock, nature's own seal. Beautiful. So the only leak is here, which we created by drilling the well to produce the water. And now imagine if you inject CO2 at a high pressure, this will create fractures in the whole rock, including this one. The compressive strength is not more than around a couple of thousand pounds per square inch. I'm sorry, not giving in megapascal. One megapascal is 145 pounds per square inch. They can convert if you like, students especially. And the rock fracture not against compressive strength, it against tensile strength, which is even far less than compressive strength. Now, let's say roughly 1/10. So if this rock has compressive strength of 2000 psi, it will have tensile strength of only 200 psi. Even with a hammer, you can create a crack in that, and you are talking about thousands of pounds. More than, let's say, at least 2,000 pound per square inch pressure above hydrostatic pressure. So you can imagine what they are doing. Okay, so now against that, let me count a few the bonanza that you get from this paradigm of producing orange hydrogen, which is hydrogen from producing inside the reservoir and bringing out the hydrogen only, and not the oil or not the natural gas, nothing else, and no obnoxious gas. So it eliminates the need for trillions worth of capex for surface process plants. Processes are in field. We call oil and gas separation facilities in the oil fields, from where they remove the salt water, they remove the wax and other things and separate gas, and the oil part they send through trunk pipelines to other seaports or refineries. And then in the refineries, you have to put the crude oil as feedstock to produce your gasoline, diesel, naphtha, light oil, and all this. So you can imagine that we don't need to do any of those things, because we don't want gasoline, we don't want diesel, which in turn will go to engines, and produce CO2. So many things we're eliminating by this, golden, pathway of orange hydrogen, and then reduces fugitive gas emission, because if those methane greenhouse gas are not coming, because we are not producing, we are not allowing them to come along the wellbore and produce and the surface facilities. So a tremendous reduction in fugitive gas emissions. This is quite very high. And that is important also because methane is 3 times more radiative. Radiative is the word in simple language, means it is 3 times worse than carbon dioxide in creating greenhouse heating effect. So you can imagine it may have a small amount compared to CO2 in the atmosphere, but it's with 3 times. And not only that, it takes a longer time for the atmosphere to get rid of it. So that's you just add them together and you get a picture how dangerous the methane and fugitive emissions can be for global warming or climate change. And adds huge oil and gas reserves. This is should knock the socks of many people. This is a very interesting point, and let me spend a minute to address the gentlemen all over there. And students of petroleum engineering, they know, but they don't feel about it. That point, with the best of technologies, we produce oil and gas, be it ExxonMobil or ConocoPhillips or ONGC or Petronas, whoever. Basically, when they abandon the oil field, they leave 60 to 70% oil there. Why? Because that is not commercially recoverable. Why? Because they have drained it, the pressure has gone down, and they put the pumps, those jack-up pumps or electric submersible pumps. But even then, when the reservoir pressure has gone down from, say, initial 6,000 pounds per square inch to an abandonment pressure of 500, this amount of barrel they produce per day doesn't justify the OPEX, operating costs. So they abandoned it. They put a few plugs, cement plugs here and there inside the wellbore, and they run away from that, whatever. But they're leaving behind 60 to 70% of the oil. So now if we are bringing this concept of orange hydrogen, then that means they're as good as new. 70% of the original oil in place is still there. 30% has been produced in the past, after the drilling and all those development drilling, that particular oil field, maybe it had 10 billion barrels of oil. So they produce only 30 to 40% of it by the primary method and the pumping and then water flooding, they call secondary oil recovery, and so the bulk of it is still there. They are real resources. Now, when you, and because now you don't have to pump them out, you have to inject hot air and it will do its job. It will cook them into hydrogen. And believe me, this is something. So abandoned oil fields still contain 60 to 70% of original oil in place. So they are the first candidate, because there is no resistance. You have those in India, in Bangladesh, in Malaysia, in Indonesia. I'm not talking about the Western Hemisphere because the obvious reason I mentioned. So, and China, you can imagine, Africa, all right? So we still have those, as good as they were 100 years ago, if we apply this new paradigm, orange hydrogen. So let me take a break here. I love green hydrogen. You do, all of us. Green is green, no question about that, but it's very expensive. Okay, if you use, for example, electrolyzer or whatever, to produce 1 kilogram of hydrogen, okay, the estimate is currently, as I know, $10. That's a way high, So I'll show some statistics. But if you do this way, the cost will be, I have not done exact calculations, but since I have done petroleum economics, so on that parity, it could be very much in the vicinity of $1 only. And what this $1 means, I'll show in the last slide. Please stay with finger crossed till that time. And the other thing I said, many countries in the Middle East and elsewhere, they have sour gas fields. They have natural gas fields, but it is not pure natural gas, not methane, a little bit of methane. It contains quite objectionable amount of hydrogen sulfide. So we call them sour. If not, it's called sweet. Sweet is sweet. You produce them, sell them, earn money. Sour, you don't, unless you have enough capital to strip that sulfur out of it and then sell it. That's very difficult. And so this can be a good candidate. Why? It is easier to convert them into hydrogen, and then with the membrane separation technology placed, a few hundred feet of the last section of the wellbore, okay, you can only get hydrogen and nothing else. Everything stays behind and locked in that nature's own seal, until God is theirs. I mean, a measure, seismic activity happens, Richter scale chain, and or whatever. So let's go forward. So having said that beautiful prospect or potential, how about the technology? Do we have proven technology for orange hydrogen? Let's see what we have. There are two proven technologies, okay, for the most of the oils that are available all over the world. They're either light oil or intermediate or heavy oil. For light oil, we have this called steam reforming method. And it is the least expensive for producing hydrogen, where light hydrocarbon is the feedstock or the source material. And in the reformer reactor, you inject steam at certain pressure and temperature, and there will be some what do you call it, catalyst, because this was done almost 100 years ago, successfully commercially proven, and then you get some hydrogen from there, that reaction, and it is hydrogen and hydrocarbon. So the carbon goes with the steam that has oxygen, becomes CO2, and the hydrogen is stripped, and then some carbon monoxide, and then if further with more steam, there is another reactor called shift converter. So remaining CO converts into CO2, and you get additional hydrogen from the steam, and so more hydrogen. And final is this called purification unit for separating the carbon dioxide and the hydrogen. And it is proven. And actually, this reforming is the opposite of the process engineering that two engineers, Fisher and Tropsch, developed in 1925. Okay, and they did it with coal. Now, coal has carbon, and steam gives the oxygen. It works whether it is natural gas or it is coal, the initial thing, or whether it is in a light crude oil. Okay, so it works, and it is the cheapest of all. The question is, can we do this surface process engineering underground? Please hold on for that. Okay, let me go. And the other one is, when you have it is similar to what we found steam methane reforming, but if you have not light hydrocarbon but heavy oils, just like in Canada, and of course with coal, that the process is changed a little separately, a little differently, but ultimately you break down those heavy molecules of hydrocarbon, and then you come to the same process that is in SMR. So it is good for oil, all types of oil, light, intermediate, or heavy. Okay, so technologically it's possible, and at the surface it has been done. Second World War, Germany did not have supply of I think the First World War crude oil, so they used coal. Fischer-Tropsch method, obviously Fischer is German scientist, engineer, and their plans produced two things: this synthetic crude oil, hydrocarbon, which could be refined and to produce petrol, gasoline, and your diesel, and also for lubricant oil. They did it. So why they don't do it again? Of course, that's another story. In the oil empire, things are happening, and I can't say anything more than that at this academic presentation. So, and the other thing is, some nice things over here. Okay. So barriers and how to overcome them. So technology part is there. We have covered partially on surface. Then we have to go to the downhole underground situation where the reactor will be not empty and a reactor vessel, but it will be porous permeable rock. So we'll address that and something else in terms of barriers. The first of all, the barrier number one is this particular box I have put, and with lots of thinking what to write, what not to write. So I have taken the middle position here to indicate what is the number one barrier. This barrier exists in the Western Hemisphere because of this reason, that the governments have been, let's say America, let's say Great Britain, let's say any other Western Hemisphere country, they have been playing the second fiddle in the energy policy development, or maybe no policy at all. Everything depended on the private big oil companies. Whatever they do, they produce oil, government needs it at peacetime, and especially at the war time. Officially, the First World War was won because of the glut of oil supplied from America to France. It is well recorded, no conspiracy theory. And the Rockefellers of America and the debtor rings of the Royal Dutch, shell company in the Venice era set the wheels of the era of oil with their empire of oil. So that's what I indicated. So government could not do anything, and the worst casualty was environment. No respect for environment. Actually, this oil construction engineering did not develop because they didn't want it. They know this is temporary, 10 years, 15 years, and they sell it to some small companies. And so they get out of all responsibilities. So now, officially, the US government is very, very worried because of millions of abandoned wells which are spewing not only oil, a large amount of gas, methane gas. And this is detected by remote sensing, period. So government, so I said how to overcome it? We have to turn east. Our government in the Eastern Hemisphere, especially the democratic governments, you know what I mean, must make their own energy policies. And they must set policies at the UN IPCC platform, starting with COP26. Let's do it. What is that? One of them is stop carbon sequestration by injection. The other thing is don't produce oil and gas anymore. And something very worse happens in Canada. They use lots of natural gas to reform those heavy oil. They call it, tar in Venezuela, and in Canada, a very heavy oil, like almost solid tar, to transport them into intermediate quality crude oil at the expense of lots of natural gas, burning of course, and emitting CO2. They are doing the opposite process. Now, we talked about heavy oil. We are converting them to hydrogen and not producing any CO2. Let's imagine that scale, okay? So the protocol number one should be, let the governments be the master policy makers for emission abatement. The Intergovernmental Panel for Climate Change, IPCC, I've been mentioning, at the UN Framework Convention for Climate Change shall reset the direction of fossil fuel exploitation. The direction is the one that let us not produce oil and gas and then refine them to be burned at the furnaces or engines and produce CO2, start to finish CO2, and other gases, but keep them in the reservoir and get only the hydrogen out of it. So it is reversing the directions. So it is last, like we say in India, if you have no head, then you cannot have headache. No head, no headache. No combustion at surface, obviously no production of CO2. Then there is no need of any CO2 sequestration. Okay, just by changing the direction, we can get rid of the whole headache. And as I said, the government, I'm restating that, shall make the rules for energy production. Now, I'm saying this mainly today to the young petroleum engineering students, because after 10 years, they'll be policymakers, or at least they'll be the one who will give data in these directions to the national government's policymakers. So that's why I'm bringing this. And they must set policies at the UN Office platform, starting with that. So that's step one. There could be more steps, but that is not the meat for today's presentations. Now let's go to the barrier number 2. We must be honest. And we must not do the same mistake, same blunder that the big oil did with respect to their old direction of producing energy from nature, hidden treasures, coal, and crude oil and natural gas. So once the IPCC takes the positive stance regarding orange hydrogen, huge collaborative R&D and field pilot projects will follow. This has not happened so far for reasons I indicated or hinted at. But if we can set the rules from this platform, then of course the governments, instead of spending money, or rather wasting money and buying epic level disaster like spewing of CO2 from deep underground reservoirs where they have been forced by oil companies, in the name of sequestration, things like that. So that money should be diverted to bring this proven technology of steam methane reforming and the partial oxidation or the cracking that is established and commercialized in some countries, especially South Africa, by Sasol Oil Company even now, but they cannot grow because of the overwhelming, pressure of the empire of oil. So it will not take more than, by 2050, if that investment is done at R&D, and of course, lots of it in the academias, okay, and immediately it will be followed as field pilot projects. And as I mentioned, for the field pilot projects, it does not have to compete with the properties of the oil companies, because there's lots of abundant oil fields containing much more oil, 70% of the original oil in place. And there is the sour gas reservoirs in United Arab Emirates, in Saudi Arabia, and many other countries. So they're waiting, okay, to come and create field pilot projects, and the money will be made available. So that will be a fast-track process if and only if the motion starts at the IPCC. And by 2050, I believe if that happens, then orange hydrogen production can meet the world's energy needs. How can I say that? I'm not shown any number. How much oil will be required to produce how much hydrogen? It is coming. So this I already indicated. Let me move further. And here is our acid test of honesty. Are we hiding something from the people, from the policymakers? No, I said that we should give them information, so, and that information-based policy they'll develop. We have to inform them, or we have to ask them for funding, research funding, to study the environmental impact of hydrogen, which can be released and will be released, of course, into the atmosphere from the pipelines, from the surface storage facilities of hydrogen. There will be leakage. So currently, the IPCC has protocols, some policies about how to minimize that, to what extent, within a time frame. I'm not going into that. So same thing will apply, but hopefully it will be less. The only big thing that may happen, that hydrogen ascends so fast from that and goes straight to the ozone layer, And we know what happens when hydrogen goes to the ozone layer, and that O3 molecules are waiting there. So it will be quite interesting thing, of course, negative. But of course, it is controllable. It can be controlled once we know how much will be leaked from where, and once we know that, we can also, take mitigation steps. Those which is released. That's a matter of research, of course. So having said that, knowing all the benefits, and that the only practical barrier is that we need to have lots of funding for research, okay, and also to develop, to study, to optimize or to maximize this conversion or the gasification of hydrocarbons stored in the reservoirs, both current and abundant, and also sour gas reservoirs, and create pilot plants. So that is the main thing, and it will happen. It will happen the way we're approaching. We're not going to US government. We're not going to big oil. We're going to straight where it counts. So, and like the ongoing ITER project in France, okay, it's a huge project. It is an international and a consortium of the technologically advanced countries, the whole European Union, United States, and also India and Japan and maybe Korea. So they have come under one umbrella to put their money, budgets, funds, and science and engineering prowess to create a massive tokamak. The tokamak, that system to make fusion commercially feasible. It is still an utopia, but theoretically it is possible. So they are doing everything practically to make it come to fruit. So far they have not been able, but they are not living it either. As of now, they are doing lots of work to make fusion possible. So if the same effort or part of it is given to develop this oil field and gas fields and even the deep coal fields into hydrogen producers, I think a fraction of that will be enough to provide the world with this beautiful, and sustainable hydrogen, which I have given a name called orange hydrogen. Okay, it's in order, and I think calling it orange is not enough for the goodness of it. It deserves to be called, in my opinion, a golden hydrogen. So if there is an ITER project, then from the IPCC platform, now we should, create in a collaborative manner, white papers based on current state-of-the-art knowledge in science and engineering, which exists plenty. And I'll give a gist of it in my follow-up presentation, either at the Basra University of Oil and Gas or any other university. That's a must for the students and professors. And then I hope that the GHI project, GHI has a very, like ITER project will come into being. GHI stands for Golden Hydrogen Energy Economy. And in my own mother tongue, which is Bangla, ghee means the butter oil. The butter oil is the best part of the milk, which comes from nature, from a cow. So let us wait for that ghee, and while we work hard to enlighten the IPCC, not from distance, but joining that forum from various sub-forums from all countries in the Eastern Hemisphere, from Bangladesh, from India, of course, China, I'm not sure, but Indonesia and Japan, Korea, for sure. Middle East, I'm not sure, because I call this oil policies are either big oil or big oil and associate. Associate is obviously understood. And we don't need that. We don't have to. We are enough in terms of number, in terms of might, and the places to meet that UN and IPCC. So that's the end of my presentation. And I know some people will ask, give us some example that it is happening now somewhere in the world. Yes, it starts from the University of Calgary. The professor, Ian Gates, a senior professor my age, and his colleague, and of course lots of user students. One of them is from India, Uneconomic from Western India. So back in 2011, they published a paper. And by 2018, I guess, they patented, of course, they have to do patent, and then they created a startup company. That startup company has now begun the operation to partially oxidize in situ the heavy oil for which Canada is famous, like Venezuela. They have more in terms of heavy oil than the combined Middle Eastern reserves of intermediate or light crude oils. So they are waiting for this technology. Just use giant compressors to inject oxygen. There will be at the bottom some heaters. It will be hot oxygen and nitrogen, and the oxygen will do its work. Okay, and where is the steam, by the way? The steam will come from the heated oxygen and air, and in the water. There's most of the reservoir is now water. After it is abandoned. In heavy oil, there is. Oh, okay. If not, you can inject steam itself. And one thing before concluding from technical point of view, steam injection, steam flooding is a proven technology. It is going on day and night right now in Canada, in California, wherever they have heavy oils. They inject steam, they got steam flooding and different configuration of wells, okay, injection and production. So I'm not going into the detail, students know about it, but just to convince or just to enlighten the policymakers, that this is a proven technology, it is going on, but in one hand, they are doing it to bring the oil out of it. On the other hand, now this recent baby has started this new one, orange hydrogen. They don't call it. They say we'll produce hydrogen from this by injecting steam. Okay, of course, the know-how is there. How hot and at what flow rate you have to inject. So that's the know-how, and that's just like in any chemical process engineering. And some reporter claims that this low-cost clean hydrogen from underground oil fires could kill off green hydrogen sector. Well, that's some observation. I don't believe in that. Green hydrogen has its own niche market. It will remain not a large scale, and maybe it will grow alongside. So one more slide is to conclude. As I promised, I'll give you some number. How much is how much? How much we can get from a given amount of crude oil in the underground reservoir. So here is an estimate by this startup group. It says that a heavy oil reservoir with 32 million tons, it's a small number, I tell you, small numbers of remaining oil can supply 500 tons of orange hydrogen. Well, how big is 500 tons? To give you a perspective, I am bringing here my favorite car, Hyundai Nexon. Okay, this is a hydrogen fuel cell operated car. One full tank means about 6.33 kg of hydrogen. Okay, and it will give you a mileage of 756 kilometers. Let's say 700 kilometers. And if you do the math, it means that for $1 per kg, that is quite reasonable. For this orange hydrogen. Currently, green hydrogen by electrolyzer is around $10 USD per kg, way high. So imagine that. Imagine that at a time which we can have if we do work the way I described the pathway of hydrogen. Okay, and I'm sorry, and a marginal, I'm giving because I'm not mentioning the name of the country, but I know I did some research project for that. And they used to call it a marginal oil field, but in Middle Eastern country. Do you know how much it contained oil? 5 billion barrels of crude oil. They are not producing. They say, no, our cost will be so high with the petroleum engineering technology. For a reason they call it, it's a very tight rock. Okay. So, so it is 5 billion barrels. Okay. So that is about 750 million tons. Remember the previous slide? It was 32 million tons. You get 500 tons of orange hydrogen. So now you can see these numbers, 750. So you can expect 100 to 1,000 plus million tons of orange hydrogen. And that will be at such an affordable price. So shall I call it then golden hydrogen? That's my last slide. I use lots of colorful graphics from numerous sources. So I acknowledge that without bringing a long list of them. So I'm grateful. I acknowledge those works of arts, science, and engineering available freely through Google search. So with this, I'll make a conclusion here that let us open a new era. Era we live in, Big Well said it's era of oil. Now let us, using the same resources, but the reverse direction, let us transform it into an era of orange hydrogen for the benefit of mankind. And of course, the main motivation is having this climate change under our control through the means of cutting emissions to zero. So thank you very much. If you have any discussion points, please go ahead.
Thank you, sir, for this valuable lecture. If anyone has a question, he can unmute himself or can raise a hand so I can unmute him.
So any questions, suggestions? It is evening, I think we're into the night, in Iraq and maybe in Bangladesh, of course, it is very close to midnight. So, but we had some good discussion before we started this webinar with Professor Yusuf. I'm very happy, and I know we're going to meet very soon. So it's a very good news for me that even before the meeting, this webinar was started. I made some good contact and will continue. So students, of course, you have not heard about it because it is not in the curriculum. So one front that we have to open is the curriculum of petroleum engineering, undergraduate studying and master's and doctoral levels, and of course lots of R&D. But nothing will start, I believe, until money flows. Instead of going to those sequestration and other fallacious ideas which stem from ignorance, and also mechanism of, should I say, vested interest.
Thank you, sir. I think now we reached the end of our lecture. Thank you for your time, dear attendants. Thank you for listening. Have a good time.
And let me give my vote of thanks to Professor Dr. Akbaruddin Ahmed from PRC of Bangladesh. I can see him here. And also Dr. Shahidul Islam is a professor and nature, sir. Thank you, sir, for joining. And this is a light version for students, but I wanted to put lots of things for the policymakers like you, or those who assist policymakers. We'll do more words. Thank you very much.
Professor Muhammad Awal, don't leave us. I have something to discuss with you.
My pleasure. Yes, sir.
Okay. Can I? Okay. As you thinking that by IPC will do something, or the global community do something within 2050. But our assessment revealed that within 2050, the carbon density level in the atmosphere air will be more than 500 ppm. Temperature will be 0.5 degree higher than what we are experiencing,
Yes.
and the total carbon amount will be 55 gigaton. And due to that, runoff water will reduce more than 50% what we have right now.
Yes, yes, yes.
With this situation, the global lives may reduce more than 50%. So with this level, how we can suggest IPPC to wait 5050? My assessment, and also our colleagues, we made assessment, the suffer we have right now due to COVID-19. By 2035, it will be 5 times higher compared to currently we are suffering. And it will be more than 10 times higher what we have now, right now. So then what is the solution?
Solution is we are all working toward that. So, and these are all estimates in terms of the target. What you mentioned correctly, that estimated carbon dioxide level in 2050. And also I studied their main attempt is to bring down the emissions, and that's why they're asking the governments. But the governments are helpless, in the Western Hemisphere, who produce the bulk of it, carbon dioxide. They say it is the voluntary actions, and the toughest thing they did in the Biden administration, that it asked the companies that you must inform your shareholders to vote about it, this emission cutting, and that means they should come forward to take some loss in terms of the share values. But that is a very temporary thing. That is a sort of pleading. So with that mechanism from IPCC, and those emissions trading, which is a big game, in my opinion. I've been studying this since 2000, and it's a big game. And so X is deceiving Y, and Y is deceiving Z, like that. So we need to bring something robust. This will be, once it is institutionalized for a powerful forum like IPCC, it will run by its own merit. It doesn't have to depend on somebody's own reactions. And the second thing is, whatever you do, then again, this most influential big oil, they put their agenda there, and it actually backfires. Not maybe at the current time, but as I showed you, that let's say, 100 years after the mega projects on CO2 injection starts, it will bring down a catastrophe worse than maybe, or the same type as COVID, in terms of human sufferings. So there is no one solution. It has to be a composite solution from all angles. You have to take green, however humble it is, green hydrogen and other green energy forms in a small, but they add up. And the other thing is, of course, I believe this hydrogen, orange hydrogen, it will be suddenly, and it will appear like a messiah, suddenly with a huge volume of energy supply without emission. We don't have to cut any emission because there's no emission, greenhouse gas emission. It is cooked underground and kept it there. So it's a giant step once it is taken. Right now, what we are doing is one small step by a human being. But when it goes down from the IPCC platform, right from COP26, that instead of asking that please voluntary, no, you have to put money for accelerating the necessary R&D to repeat as a viable, as a proven technology, what has been done 100 years ago on surface plant, same chemical process engineering, but now with a little tweaking to do it in underground oil and gas reservoirs. So whether it will happen by 2050, it depends how much we become successful to deliver the message, not deliver the message, but work with IPCC is out there and through the different levels, the best policies. We work on the each government, countries' governments, these corridors. India has created a new ministry, for the hydrogen and renewable energy, and I think they're serious because they have to be. They need. We lose our foreign exchange, paying for those, this foreign crude oils and oils. So does China. So I can see, lots of silver lining in the dark cloud. And so at this old age, I'm very as optimistic as a young engineer that I was, and I believe together we can, generate in a synergistic manner more ideas to find that corridor, okay, within our governments, and then through our governments, for example, I watched that last week, Prime Minister Sheikh Hasina's speech about, asking the rich developed countries to do their share of work. It's kind of a pleading. It's better than nothing, but we can do better. We can make, strong schemes and submit it at the IPCC, and the benefits should be obvious, to them. The way should prepare, minimizing those technical languages and making use of the common languages, which I tried today. They'll understand. There's no rocket science. It's a very old technology, but shoved under the carpet. This, the reverse process of future crops, well proven. So because of historical things, it didn't come where it should have gone. But now, we have a chance. We have a chance. And of course, behind all these things is the Creator, the Lord, is watching our effort. He will reward our good efforts, no matter whether it comes from India and Bangladesh and Japan. Good work is good work. Okay, so that is not, talked about, but we keep it in our heart, and that gives us the strength to think positively and bring out solutions or the pathways, as I said today. And the solution will be there. Like nobody believed COVID will have a vaccine. Suddenly it came from two persons, that too not from America or Germany, to Turkey, a couple, husband and wife from Turkey, and working in Germany. So, and nobody believed, those skyscrapers in which Rockefeller built, those are junks. But one man, single man, Fazlur Rahman Khan, in the late 50s and early 60s, he gave the world the modern concept of skyscrapers, which is lots of usable space. And I think, so this happens. So we have to trust ourselves. I trust, and I trust you, you trust me. Let's work. If one single person could do it, FRK, have you visited that Sears Tower, now renamed Chicago? I have. And that's a moment. So solution is there. Only thing, we have been far away from the power center, which is the IPCC. And the good thing in the Eastern Hemisphere, we are welcome with our ideas, science and technology, and what you call it, the business ideas around it. Thank you very much, and we'll meet. And I'm very pleased that
I have another point for you. You may put some idea, though it's too late. Idea is, it looks the world community, those who really got the power, they are busy with the geopolitics, not much time is spent for the crisis of the energy and energy related disaster issue. They have
Yes.
not enough money to research for our young researcher. They have not enough money to do piloting, but they have money to prepare weapon to kill each other. So it means there is something wrong in the global management. That's why they are not listening to us. This money really is make me very upset that we are moving in the positive direction, world management moving in the reverse direction. We work to save people, they work to kill people.
Yeah.
So what is your opinion in this regards?
Yes, I have studied that so-called, the oil politics, being a petroleum engineer, professor, researcher, and my own interest. Why the two world wars happen, and what is the war of oil? All these kind of things. Everything, those presidents, at the most powerful democracy, their hands are tied, because the bad thing about that powerful, democracy is that the lobbyists, those who work in the corridors of power, they make the policy not for the people, by the people, okay? By the people, but not for the people. And those presidents, no matter how good he could be at heart, when they retire, you meet them, they'll say, my hands are tied. My hands are tied. So many of them say very good things after retirement, okay? You can take Jimmy Carter, for example, or Barack Obama. Forget Trump's, of course. And I'm sure Biden himself will have lots of stories to tell. Well, I tried. Forget that. For their own people, the middle class and the downtrodden, they don't have life insurance, and it is because of the insurance lobby. They have coal lobby, insurance lobby, then of course the petroleum lobby, which is this giant, and of course the automobile lobby. They don't allow them to lay railway roads because they want to sell car, and they have to sell car which guzzles gasoline, and only because of the environmental concern, they are asking them to reduce, increase the mileage, but they want gasoline guzzles. And I pulled out some slides. I showed exactly, that how this heavy oil, of Canada is transformed into intermediate oil, and that oil is exported to US. So the US imports only 22% of its needs from Saudi Arabia, 20% from Nigeria, but bulk of it comes more than that, 30%. It comes from Canada, only to keep their refineries running, where the big oil has employed trillions of dollars to running. See, so it may almost sound like a conspiracy theory. No, it is hard fact. If you put those dots connected, you'll see, and why there's that Keystone pipeline was being allowed to bring more of that crude oil to Houston and Texas to refine, where they have the old but $1 trillion worth refineries. So it's so I have gone through that maze, and that's why I can see clear picture. But then putting the knowledge together, I can also see the silver lining. And the only thing needs to be done, that you and I, we sit together and develop these plans and make them stronger to the extent that it stays, once it is tabled at the IPCC forum through some government, representations in India and Bangladesh. It will work, no question about that. The proof is that now the oil companies in America, they have been asked to show their plan for cutting emissions, but they're clever enough. They said, no, we'll do it, and we'll take your emissions, we'll put in the deep seas through our wells, which is fallacious, and I have shown you that. And so that is one of the main reasons why I'm speaking from India and working from India now, although my family lives in America, and I'm still connected, but my work will be from here, from the Eastern Hemisphere with you. And so we'll have so many like-minded people. And I've read some article in Indian newspapers, retired IAS officer, IFS officer, they're writing about this. mainly about green hydrogen, of course, because they do not know about orange hydrogen. That's why I'm putting this on a top priority. Let them know, and with their partnership in this movement, and things will reach to IPCC. And I'm very optimistic, and for a good reason. Thank you.
Thank you very much, sir.
Welcome.
Thank you, professors, for this great discussion. I think we reached the end of our lecture.
Mhm.
So,
Thank you very much.
thank you to all attendees. Thank you for listening. Have a good time. Thank you.
Thank you very much. And
Thank
I'll have discussions separately with Professor Mazhar al-Haq. Thank you, Dr. Professor Mazhar al-Haq. Thank you. Salam alaikum.
Wa salam. Thank you. Thank you.
Thank you, Sir Akbaruddin Ahmed,
so
sir.
much.
Thank you very
Thank you.
much. You stay with us, and here we are about 2 o'clock in the morning in Malaysia. But still, you look young, Professor, and waiting with us. Thank you very much.
Thank you so much, sir. Thank you. Thank you.
Well, thank you so much to all of you. Especially, I could see my mentor, Professor Akbaruddin, all the way from Bangladesh. And it's well, we are not, we're a little lucky. It's 12:30 at Toronto, so it's a beautiful morning as of now. So quite sunny, beautiful morning. Little cold, little cooler though. In fact, yes, we are all attending the World Conference on Disaster Management, at IIT Delhi. Although I won't be able to join physically, but through Zoom, I understand Professor Akbar would also be joining through Zoom this conference. So, in that conference, we also have similar topic like I have this disaster management on indigenous knowledge and technology. But coming back, can I take a couple of minutes, Professor Awal? Can I take a couple of minutes? Okay, thank you so much. Thank you so much. Okay, this orange hydrogen is really something exciting, really, to me. Something exciting, it's not known to us. To me, orange hydrogen and also issues like blue and gray, all sort of stuffs are so new to us, I've been working with IPCC quite some time, for last 1 decade rather. I was with the Ministry of Environment and Forest of Bangladesh, and we were attending all these COP meetings. Now the COP26 taking place. So at the COP meeting, these issues are not that much well talked about, and how we can tackle this energy issue with orange hydrogen and bringing zero carbon emission. These are some things I would strongly suggest, Professor Awal, that if we could have maybe some sort of small leaflet or some flyer, so that exactly, flyer.
Yeah,
what is meant by hydrogen? Yes,
like an executive summary, but below it will be a thick white paper with all the data.
No problem. We need something abstract one, so that maybe 1 page or half a page. What is meant by orange or blue or gray, and how it's going to elevate, especially in Bangladesh. We are having a lot of caricature with energy issues. I'm using the word caricature. Like we are importing coal, and then we are importing all fossil fuel based coal. Now we have come to know that we have more energy than we need. So forgetting about the renewable sources of energy. So this energy issue is something really bothering us. And as you rightly mentioned, that some of the multinational companies, they're coming up with big agendas, and their political leaders, so they're quite strong on that. So based on that, I would strongly urge upon you that perhaps with in fact, I was a policymaker in Bangladesh for last 30 years. and the policymakers are to understand what is meant by orange hydrogen, and because they are going to IPCC meetings, they are talking there, and they are discussing about carbon sequestering. It seems apparently it looks innocuous. Carbon sequestering, apparently innocuous, but when you are going through this well, digging in, and then this is something it could be destructive. So it has to be brought in the to the notice of the policymakers. I wish you good luck, Professor Awal, and
thank you.
With Professor Shohidul Islam, we'll be having more conferences, especially at Delhi.
Sir, I want to tell you something about Bangladesh and India. My study says that yes, we have some potential of orange hydrogen or green hydrogen, but the amount of waste biomass we have in the India and Bangladesh, if we use the simple technology like gasification and pyrolysis, it will be cheaper than the produce green hydrogen that we are now producing here in my lab from the waste biomass like kathal, collard sugar, and even the what we call sugar bagasse. Even the amount of waste biomass we have in the Kornofuli and other area where we have the huge forest area, you will be surprised 1 kg waste biomass is able to produce 1.5 kg hydrogen. And 1 kg hydrogen is 155 megajoule of energy, that is 5 times higher than methane.
Yes.
So it's no point for Bangladesh to import